Centauri B is an Earth-like planet that circles around the closest star to Earth. What a coincidence that Michio Kaku's discovery of new planets, which are even better for life than Earth, has jolted the scientific community. You might already be aware of the existence of habitable exoplanets. These are planets in our galaxy that are Earth-like. While the conditions on Earth are pretty decent for life, why settle for decent when you can aim for the best? Planets that offer more land, balanced temperatures, fewer deserts, and an abundance of water suggest that somewhere out there, paradise exists. However, we are talking about the future of humanity, and scientists have found some top contenders. Join us as we explore these fascinating planets and how we might reach them. Super-friendly planets or super-habitable planets are those that may offer an even greater potential for hosting life compared to our beloved Earth. In 2014, Renee Heller and John Armstrong proposed this concept. They argued that merely identifying a planet within its star's habitable zone is not enough to ascertain its true habitability. The assumption that Earth, as the sole inhabited planet known to us, possesses the most suitable physical and chemical parameters for life is not entirely clear-cut. Life depends on the existence of liquid water, which is why we search for Earth-like exoplanets. However, some researchers suggest that other types of planets might offer equal or even better conditions for life compared to those on Earth. The quest for superhabitable worlds embraces the possibility that planets need not resemble Earth to harbor life, but could offer even more favorable chances for the emergence and evolution of diverse organisms. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world, whether a terrestrial planet or moon, could potentially support a richer array of flora and fauna compared to our own planet. Such a world would exhibit a greater degree of environmental friendliness towards life. Furthermore, not all rocky planets situated within a habitable zone can automatically be deemed habitable. For instance, tidal heating may render terrestrial or icy worlds habitable beyond the boundaries of the stellar habitable zone, as observed in the internal ocean of Jupiter's moon Europa. Some scientists argue that our fixation on Earth-like worlds may hinder our exploration of exobiology and the diverse possibilities it holds. Identifying superhabitable worlds requires a shift in perspective, focusing more on biological reasons rather than geocentric or anthropocentric reasons. Anthropocentric refers to a perspective that places human beings as the central and most significant entity in the universe, while geocentric means evaluating everything with Earth as a center of reference. Astrobiologists believe that our focus on finding a second Earth might cause us to tunnel vision and neglect other possibilities, like planets that could be even better than Earth. The concept of superhabitable planets can sometimes be challenging to convey, as it requires questioning the assumption that Earth is the pinnacle of habitability. While our planet boasts an impressive array of complex and diverse life forms and the ability to thrive in extreme environments, this does not necessarily mean that Earth represents the epitome of habitability in all aspects. To broaden our search, Heller and Armstrong proposed establishing an exoplanet profile encompassing various factors such as stellar type, planetary mass, and location within the planetary system. The search for life now goes beyond yellow dwarf stars like our Sun. Scientists also look at planetary systems associated with orange dwarf stars. These stars, cooler, dimmer, and less massive than our Sun, offer an alternative perspective for hosting planets with abundant life. Our Sun is not the best kind of star for hosting a planet with lots of life on it. This perspective challenges the assumption that Earth's solar system represents the ideal template for life elsewhere in the universe. In the vast expanse of the Milky Way, red dwarf stars outnumber yellow dwarfs by approximately 50%. Unlike our Sun, which has an estimated lifetime of less than 10 billion years, orange dwarf stars boast much longer lifetimes, ranging from 20 billion to 70 billion years. This extended lifespan offers planets within their habitable zones more time to foster the development of life and accumulate biodiversity. Considering that complex life on Earth took around 3.5 billion years to emerge, older planets possess advantages but must not be too ancient. Over time, these planets exhaust their internal geothermal heat and lose their protective geomagnetic fields. Therefore, researchers propose an optimal age range, referred to as the sweet spot, which lies between 5 billion and 8 billion years. In comparison, Earth is currently around 4.5 billion years old. Mass and size are also crucial. A planet's ability to host life is closely related to its size and mass. A planet larger than Earth would have a larger livable surface area, potentially nurturing a more extensive and stable atmosphere. Optimal circumstances for life may exist on a planet that is 10% larger than Earth. Furthermore, if a planet has 50% more mass than Earth, it will produce a continuous source of heat due to the extended duration of radioactive decay within its interior. This, in turn, would keep the planet's molten core and crucial magnetic field intact for a longer period, expanding the window of opportunity for the birth and evolution of life. More mass also results in increased gravitational effects, which help the planet retain its atmosphere for longer. The longer the atmosphere lasts, the better it is for life. However, greater gravity would make it harder for humans to move around if we ever visited such a planet, but this may be a minor issue compared to the challenge of reaching such a planet in the first place. Temperature is important too. Worlds that exhibit a slight temperature increase of approximately 8 degrees Fahrenheit compared to Earth could potentially be superhabitable. This is because a warmer planet might have larger tropical zones, which, as observed on Earth, foster greater biodiversity. Tropical rainforests, characterized by their warm and moist climates, host a remarkable diversity of life compared to other regions. However, warmer planets may demand even more moisture due to the expansion of deserts caused by increased heat. After all, water is a fundamental requirement for all life on our planet and plays a pivotal role in the search for habitable worlds. Additionally, planets with landmasses similar to Earth's in size but divided into smaller continents may offer a more hospitable environment for life. When continents were very large in the past, like the supercontinent Gondwana 500 million years ago, their interiors were far from oceans and turned into enormous hostile deserts. In our own world, the shallower parts of our seas support a wider diversity of life than the deepest parts. As a result, scientists have begun to hypothesize that planets with shallower water masses would be better suited to hosting a variety of life forms. While some of these conditions remain beyond our current observational capabilities when it comes to exoplanets, researchers continue to search for these indicators. In this pursuit, Alpha Centauri b has emerged as a particularly promising target for the discovery of a superhabitable world. Alpha Centauri b is part of the stellar system closest to our planet, Alpha Centauri. While the potential of the system is quite exciting, we haven't confirmed any planets in Alpha Centauri b yet, much less superhabitable planets. One was reported in 2012 but was disproven in 2015. Another was thought to exist according to observations in 2013, but it's still unconfirmed. So, there are no known worlds in Alpha Centauri b. But what about its neighbors like Proxima Centauri? Proxima Centauri is a red dwarf and it could have habitable or even superhabitable planets as well. The added bonus is that it's only 4.2 light-years away from Earth. So what kind of planets does it have? One planet is Proxima Centauri b. It's an exoplanet residing within the habitable zone of the red dwarf, alongside its disputed counterparts, Proxima c and Proxima d. It stands as one of the nearest known exoplanets to our solar system. Is this planet habitable? Well, not as much as one might think. Significant obstacles prevent life from thriving on Proxima Centauri b due to a number of variables. The star's activity and the tidal locking phenomenon make it difficult to live on this planet. The UV radiation emitted by Proxima Centauri is comparatively redder, resulting in potentially reduced interaction with organic compounds. Additionally, this UV radiation may generate lesser amounts of ozone. The star's activity could even disrupt the ozone layer, leading to heightened levels of UV radiation that could prove detrimental. Depending on the eccentricity of its orbit, Proxima Centauri b may temporarily lie outside the habitable zone during certain portions of its journey. This fluctuation could impact the planet's potential for habitability. Another aspect to consider is the presence of oxygen and carbon monoxide in the atmosphere. If accumulated in excessive quantities, these gases could become toxic. On the other hand, higher concentrations of oxygen might aid in the evolution of complex organisms. If Proxima Centauri b hosts oceans, tidal forces could cause coastal landscapes to undergo cycles of flooding and drying. These variations might trigger chemical reactions conducive to the development of life and promote the emergence of biological rhythms similar to day-night cycles. Proxima Centauri b is tidally locked, so it wouldn't experience day-night cycles normally, but these cycles of flooding and drying could also facilitate the mixing and distribution of nutrients in the oceans and stimulate periodic expansions of marine organisms, similar to red tides observed on Earth. While red dwarfs like Proxima Centauri boast extraordinarily long lifespans, surpassing that of our Sun by a considerable margin, the radiation emitted by Proxima Centauri is not conducive to oxygen-generating photosynthesis. Proxima Centauri may support an oxygenic photosynthesis, but it's hard to determine that with certainty. A study in 2017 suggested that a photosynthesis-based ecosystem would be about 20% as effective under Proxima Centauri's light as compared to our Sun. That would make it hard to generate enough energy to sustain life on a large scale. But let's look back to the Alpha Centauri system. Although no confirmed planets have been found in Alpha Centauri b, it would be an excellent place to look. We could look at it with the James Webb Space Telescope, but there is a more exciting idea. The Breakthrough Starshot project is a venture to develop a fleet of tiny, light-powered spacecraft to journey to the Alpha Centauri star system, the nearest neighboring star system to Earth. This ambitious initiative envisions launching these miniature spacecraft at speeds of up to 20% the speed of light. Once operational, the mission would enable the spacecraft to reach Alpha Centauri within approximately 20 years, and during its voyage, it will capture images and scientific data of the stellar system, searching for habitable planets or even superhabitable planets. If the Alpha Centauri system does contain planets with liquid water, the odds of them being superhabitable aren't bad. There's much more we don't know about the closest star system to Earth, but the more we learn, the more exciting the possibilities become.